Find the 100th derivative, g100 of x, for the function g of x equals 1 over x. So g of x here is the quotient of a constant over an expression involving x. Since the numerator is a constant, there's no need for the quotient rule. We can move the denominator to the numerator and rewrite it as a negative exponent, x to the negative 1. And in that way, we can use the power rule for the derivatives. The first derivative will be bring down the power, negative 1, leave the x alone, subtract 1 from the power. The second derivative will be bring down the power, multiply, and that'll be a positive 2, subtract 1 from the exponent, and it'll be to the negative 3. The third derivative will be bring down the negative 3, we have a negative 6, x, and then subtract 1 from the exponent, that'll be a negative 4. The fourth derivative will be bring down the power, multiply them, that'll be a positive 24, x raised to subtract 1 from the exponent, negative 5, and on and on. Now we're going to want to see if we can formulate a pattern here to speculate what the 100th derivative will be so that we don't have to take 96 more derivatives. That could take quite a while. The first thing to notice are the signs of each of the derivatives. The original function was positive. It was x to the negative 1, but it was a positive value. And then the first derivative was negative, as you see there. The second derivative is positive. The third derivative is negative. The fourth derivative is positive again. So we have an alternating positive, negative, positive, negative. Notice that every even derivative, the second, the fourth, those are positive, and the odd derivatives are negative. Now, the g100 of x, the 100 derivative we're trying to find down here, is an even number, so we will definitely have a positive. Another thing to notice is the number, the coefficient sitting in front of the x. Now, the first one is a negative 1, as we see here. But when we take the next derivative to go to the second derivative, we brought down to negative 2. Now, overall, that made it positive, but we had the 2 multiplying with the 1. And then we subtract 1 from the exponent. The next derivative, we bring down the negative 3. That's why it went to negative, and we multiply the 3 with the 1 and 2. And then x to the negative 4. And the next one, bring down the negative 4. That's why it went to positive. We have a 1 times a 2 times a 3 times a 4, and then x to the negative 5. So if you look at the numbers sitting in front of each, the first derivative has a single number, 1. The second derivative is 1 times 2. The third derivative is 1 times 2 times 3. The fourth derivative, 1 times 2 times 3 times 4. So from this pattern, we can see that the 100th derivative, we've already determined it will be positive, but the number will be 1 times 2 times 3 times 4 times all the way up to, we have 98 and 99, and it will finish off with 100. All of those numbers multiplying each other. Okay, and then the last thing to notice is the power of x's. We have the first derivative was x to the negative 2. The second derivative was x to the negative 3. The third derivative was x to the negative 4. The fourth derivative was x to the negative 5. So it's certainly x to a negative power. And if you look, the power is not only negative, but the number is one more higher than the order of the derivative each time. First derivative is 2, second derivative is 3, third derivative is 4, fourth derivative is 5. The 100th derivative will be the 101st power, and they're all negative, so negative 101. Now we can write this a little bit nicer looking. First of all, we say it's positive, but we have 1 times 2 times 3 all the way up to 100. We have a name for that. That's 100 factorial. That's what factorial means, is the multiplication of all integers starting at 1 all the way up to the final integer of 100. And then we have x negative 101 exponent. Since it's a negative 101 exponent, we can move this to the denominator and call it a positive exponent. And we can write it as 100 factorial divided by x to the 101st power. And there's our 100th derivative, g100 of x.